Hey everybody, welcome to episode 8 of the Blueprints to C++ Programming Guide. In this video, we're looking at the basics of structs in C++. So today, we're talking about structs in general, then how to create a struct in C++. We are talking about specific things, how to add constructors and operators and equal functions to your struct. And then the tip of the day, we'll look at how you can use a struct as a key for TMap. And in this video, I will use a struct that I created for my own game. So it's a real life example of how structs are used. So let's have a look what structs are all about. I got this from the Epic Online Unreal documentation, so I'm not going to read this. But in general, what structs are used for is they are best for simple data types. They allow U properties, but not U functions. And they are not managed by the garbage collection system. And usually what they also are used for are stuff like when you use data assets and data tables in C++, you need a struct to define the values that are used by the data asset or the data table. And as a side note, a struct in general is similar to a class. In fact, they're the same internally, but in a struct, all members are public by default. And the way that it's used in Unreal C++ is that these classes are not created on the heap, only on the stack. So there's no need for managing pointers and using the garbage collection stuff. So if you need more complicated things that are managed by the garbage collection system, then you should create UObject or AActor subclasses instead. How to create UObjects will be coming soon. Actors we've covered already. So let's have a look at how we can create a struct. Usually in blueprints, you're going like under blueprint structure, then defining the structure. You can add new variables, define what they are, and so on and so forth. In C++, let's delete this again. In C++, it's a little bit different, and there's no way to use the wizard to create a struct. So if you're looking at show all classes, typing in struct, there's nothing like what we can use for creating a struct. So what I usually do is create none, go on next, and then define my struct name. And I call it crit index. I'm creating a crit-based tactics game, so this is why I need the crit index, and I want to show you or use this as a basis to show you how to create a structure in C++. So we are creating the class, and once it's created and compiled, I'll be back. Okay, welcome back. So Rider opened, and the class the file that got created was the critindex.h and cpp file, and it created a basic C++ class. So the first thing that we need to do, what I usually do, I only put stuff in the header file for structs and not in a CPP. So what we can do is select the crit index, right-click, edit, delete. We don't need the CPP file. So in the H file, what we will delete is all this stuff. And I show you in real time how to create this struct. So the first thing that we need to do, and this is what all classes that use the C++ framework need because stuff is generated. So the first thing that we need to do is say crit index.generated.h. So, and this, like you know, is always needs to be the last include before the declaration of the actual struct or U class or whatever. So what we need to do now, first define it as a struct, get rid of the API call, and let's call it fcrit_index. This is our struct. And like I've said in the slide that by default, you can see it here, everything is public by default in a struct. So let's delete this and let's delete that for a second. And as you know from the UCLASS Macro, structs use something similar. They use the USTRUCT Macro, and we will define it as blueprint type. Like USTRUCTs and Or like UCLASSes, USTRUCTs also have specifiers and meta tags, but usually this one is the most important one to make your struct visible in Blueprint, that you can use it in Blueprints as a type. You will need to specify it as Blueprint type. In the slides, let's go back for a sec. There's the link to the structs section in the documentation, and I will put this in the description down below. So there you can find some sections on the specifiers and meta tags and so on. So I'm not going into this. It's similar to what you've seen with U properties and U functions and so on. But let's just continue. So what we need is the generated body macro. And now we can start by adding our types. So U property, and we define it as blueprint read write. And let's call it int32x equals 0. And let's copy this and define it as y. So it's the xy coordinates of that grid index. And I will show you later why I did this in the tip of the day, what I need the grid index for when I use it as a key for TMap. So let's continue. So this is basically a struct, and if we compile, it should compile perfectly. And so it did. So if we, for example, go to our map actor from last episode and just define a grid index and call it index, you can see I can define it. I can say index.x equals 0 or 12 or whatever, and so on. And it included the grid index automatically here. So this is our simple or the simplest struct that we could create. So the struct has the USTRUCT macro, it needs the generated body macro, and then you can define your properties. And you can also define like a function, call it void initialize or whatever. And this function can't be a U function, only a standard function in that structure. And you can have a look, for example, at the f vector, at the f rotator, and so on, all these structs that are part of the game framework, and have a look at how they did it and so on. I'm not going to add any functions right now. So this is like a standard struct that you could create. But there's something missing. Or if you would want to do something like f grid index and pass values in the constructor, there is the constructor missing. So you would ask yourself, how would you create a constructor in a struct? So let's have a look at how we can do this. Underneath the generated body, we are doing a force inline, which forces the compiler to inline this constructor, and we call it f grid index. That's the default constructor, which is defined by default when we just declare it like this. So there's nothing else, but when you want to declare another constructor, and let's do explicit force inline and declare f grid index int32 in value, and let's declare another in x, int32 in y. So we have defined 3 different constructors: the default one and 2 explicit ones. I will explain in a second if you don't know what explicit and implicit constructors mean. We'll cover this in a second. So now we declared 3 constructors, and let's put the implementation down here. So force inline f grid index f grid index. This is the default constructor implemented. And let's copy this, do the same with const int32 in value. And the way you pass or if assign values in a constructor, you do a colon, then the variable name. And let's say for this one will set all variables inside to the same value in value. And then we copy this and say const in x, const in 32y, and we pass in, in y, of course, in x, and in y. And when we go back to our map actor, you can now see that it's using the constructor and setting the values, or we can even do like do index 2 equals 12 only, and then it uses the in value or the first constructor. And this is how you create constructors in C++ in Unreal. And one thing to note is that the constructors and some other stuff we are doing soon needs to be placed in the header file. And there's no problem doing it like this. So these are the constructors. So you might be wondering what is explicit if you're not coming from a C++ background and so on. So let me explain what it means. But first, like I want to show again, we have these slides, and these slides can be found again in my GitHub repository. So here we're doing a recap about creating a struct, about showing again how constructors are defined. And then now this is what I want to explain: implicit and explicit constructors. So the explicit keyword prevents us from unwanted implicit type conversions, and it's used in declarations of constructors, as you've seen. Except for the default constructor, all other constructors are used for implicit type conversions. So what does that mean? It does mean if we are not defining a constructor as explicit with the explicit keyword, we can do a declaration that would be perfectly legal, like fgrid index equals 17. Which is equivalent to using the constructor with that int value. But sometimes this is really error prone and you don't really want to allow this. So what you usually do is define your constructor explicitly that these conversions, type conversions, are not allowed, and the compiler will tell you that it's an error, that it's not allowed. So then only when we explicitly define a constructor, then only statements like the following would be the ones that would be legal, and that statement from above would be illegal. So let's go to code, for example, and let's say we remove this explicit from this constructor. And what you can see is that we could compile it and it works perfectly. And what you can see, what writer, for example, shows you as a notice non-explicit converting constructor. This means that we can do things like this now. Of course, we need to define it as index 3. And this is perfectly fine, and we can compile it and you can see that it works perfectly. But if we do the explicit again in front of it, then you can see no matching constructor is found because the compiler really forbids it, or it's now illegal to do this statement. And this is what explicit and implicit type conversions are. So that's that. Next up are operators. So let's say if we define our index, call it index 1, for example, index 2, and would want to see if index 1 is equal to index 2. And I mean, you've did it probably with f vectors or other structs, and you're wondering why is this not working? Because we need to define a specific operator in the struct for this kind of statement to work. So let's do this. Under here, let's define a bool. An operator is nothing else. It's a special keyword, and it's a function call. So we define the operator equals with the grid index reference for value and define it as a const function. And what you also need to do is for, let's say, you can see now we defined it and the error is gone. But if we want to do not equals, then we need to also specify a not equals operator. And then there are so many operators we just keep it at these two right now, but there's greater than, less than, and so on that you can all implement like this in that struct. But we also need to, of course, implement what these functions are doing. Okay, so let's implement this. Do a force inline again. Bool, or let's copy this. And usually you can do it with writer auto generation and stuff, but let's do it like this for once. And the same thing for equals. And now we just need to do the logic, compare what we need to do to compare is it equal or not. So we return x equals v dot x and y equals v dot y. And the same thing here. Of course, it's not an and, it's an or, and not equals this and not equals that. So this is how we would define the operators for a struct. And if we compile now, you can see it works, and you can do like equals and not equals. So this is how to do operators. And then here's something that I kind of like when I created this struct or looked at how to create structs and all that stuff. I looked at the F vector, F rotator, and structs in the game framework, see how they did it. And I stumbled also upon some functions for equals and all components equal. So I just wanted to put it in that you can use it also in your structs if you're comparing, is this equals to? There may be functions in the framework that use equals and all components equals. So for now, let's do this. So I'm not going to type this now, just maybe copy and paste this and declare the function or the functions down below. So what they're usually doing is a tolerance, which in this case is a default value, kind of small value. If we go in there, it's a real small value that they're comparing it. So this is something that you can then use in your own structs. Not every struct needs operators or equals methods and so on. What I usually do is add constructors because sometimes it's a lot easier to define, like you've seen here, define values directly and not just first needing to do something like, okay, f grid index idx and then setting the values and so on, idx.x equals 12 and idx.y equals 10 or whatever. So these are 3 lines and what you could do in just 1 line. So this is what those constructors are really good for. Okay, then we are almost at the end. So it's time for the tip of the day. What I kind of declare or use this class for in my game, when I create a grid, for example, I have a class called a grid tile, which is an actor. I mean, of course, you will get errors here. And what I have usually is I have a TMap, or in my grid manager, I have a TMap of type F grid index and a grid tile actor, and call these grid tiles, for example. So for the grid index to work as a key for a TMap, let's specify, for example, we have grid index and define a cone actor, for example. So we have specific cone actors at a certain location. If we would compile this now, this doesn't work yet. We will get errors. And one error is that it's missing a get type hash. None of the overloads could convert all the argument types. So the hash map is usually used inside of maps to compare keys or quickly find the key in the map. So we need to create now an overload of that get type hash function. And this is, I will copy this for now, not type it. So this function is not defined in the struct. It's just a global function defined in map.h from the game framework. and we define an overload of that function with our grid index as a const reference. And then that's what I found out. They use this function definition to create the hash value for that struct. And now if we compile, you can see it worked, and we can now declare or use our struct as a key for our maps. And so that's the tip of the day. You can find a explanation again in the slides. And this means like we are at the end of the video. So thank you for watching. I hope you enjoyed this video. If you have questions, please leave them below in the comments. I'll gladly answer your questions. So if you want to get notified when new videos are coming out, then please subscribe. The next video will probably be about enums and how to create enums enumerations in C++. So thanks again for watching, and see you in the next video.